Hello. Today is day 2 of the first week back from spring break. You're going to click right here for today's assignment. Our goal is that you will state and apply the formulas for volumes of cones, spheres, and pyramids, state and apply the formula for the surface area of a sphere, and solve real world problems involving volumes of cones, spheres, and pyramids. This video will be placed right here. And then when you're finished, you'll click here for your assignment. Let's get started on the lesson. So, again, here are our goals today. I want you to look at this picture. And so, imagine the truth is a sphere. This is what I used to think caused arguments. The sphere is all black. The sphere is all white. This is what I think now. The sphere is all black. The sphere is all white. So, for those of you sitting at home that may not have anybody to look, or to discuss this with, you can see that this person here can only see the black side, and this person here can only see the white side. And they're arguing because they have a different perspective of the sphere. And they get mad and walk away from each other thinking that they're both right. But in reality, they both are right because they can only see what they see. Sometimes this is what happens when we look at our problems up close. We can only see the part that we're closest to. And so one thing to consider is to step back and take your time and listen to what other people's viewpoints are. So a sphere has two formulas. One is for volume. Volume is the everything that will fit inside of a shape. So the volume formula is 4/3 times pi times the radius cubed. The surface area is the outside. So imagine that you're wrapping a present or something like that. It's the outside. It's the amount of wrapping paper it takes to wrap it. And that is 4 times pi times the radius squared. You might consider writing these down. You'll need these for some of the questions later on. Now, for your first example, it says find the volume and the surface area of the sphere is if the radius is 8 centimeters. So one of the things that I like to do is right here is our volume, right? So we're gonna write it out. 4/3 times pi times the radius cubed, which in this case is 8. And the first part says record your answer with pi. So it wants you to leave pi alone. So what you're going to do is you're going to take your calculator and you're going to enter in 4/3. Remember, fractions are division. So 4 divided by 3 is 4/3. Times, we're going to skip pi, 8 cubed. We hit this A to the B button and press 3 and it gives Q. So cubed. So this tells us that this is our answer here. So 4 divided by 3 times 8 cubed. And it wants us to round to the nearest hundredth. So we're going to look at this third number here. And that tells us to put 682.67. 682.67. Now that would be the volume. Now, if we do the same thing for pi, or I'm sorry, for the surface area, we're talking about doing, so this is what the volume was. For surface area, we're talking about doing 4 times pi times the radius squared. Bring our calculator back. We plug that in. We're going to do everything except for pi. So 4 times 8 squared, which gives us 256. So we would just enter in 256 here. Now we did everything but pi in these two. See how pi is still there? So all you really have to do is type it in the exact same way. 4 divided by 3 times pi times 8 cubed. That tells you 2144.66. Now notice that this is a 0 here, so we're going to leave it as 66. So we would put here 2144.66. And then for the surface area, we'd do the same thing. We would do 4 times pi times 8 squared. And this time, the third digit is a 7, so we're going to change this 4 to a 5. So we would put 804.25. Now, one thing that's interesting is these two are equal to each other, and these two are equal to each other. They're the same answers. The only difference is this one has pi in the answer, and this one has pi in the answer. Other than that, both volumes equal the same amount, both surface areas equal the same amount. Something to consider, that these are the same thing. So the volumes are the same, and the surface areas are the same. We use the same radius. The only difference is we didn't multiply by pi in the first one. Sometimes it'll ask you to leave your answer with pi. Sometimes it will ask you to round to the nearest 100. So for this one, it says 2 solids are described in the list below. One is a sphere and has a radius of 6 inches. The other is a solid cylinder with a radius of 6 inches and a height of 6 inches. What is the difference between the volumes in cubic inches? So first things first is, here's the volume of a cylinder's formula, and here's the volume of a sphere's formula. So the first thing we're going to do is let's do the sphere. So I'll put S for sphere and volume. So we're going to do the first one to figure out the sphere. So notice how it has the answers in pi. So we're going to leave our answer in pi. So we want to do 4/3 times pi times 6 cubed. And we're going to bring back our calculator, and we're going to type it in just like that. 4/3 times, I'm not going to do pi because it's going to leave our answer that way, 6 cubed, 288. So the surface area, or the volume of a sphere, is 288 pi. Now the cylinder is pi times the radius, which is also 6, times the height, which happens to be 6 as well. So we'll bring back, so we're going to skip pi. We're going to do 6 squared times 6, which gives us 216. And since we didn't do pi, pi stays in our answer. And then it wants to know the difference. Difference means to subtract. So we're going to take 288 minus 216, which tells us 72. And pi stays with it. And so we can see that A is a nice choice there. We're going to go ahead and go on to the next problem. So it's your turn. I want you to take the time and solve these here. Take your time, read it. It says, the first part says, calculate the surface area of the sphere. Use all that apply. One thing that we didn't discuss, and hopefully you probably already know, is that the distance from one side to the other side is called the diameter. Halfway is the radius. So if all the way across is 12, halfway across is 6. So just so we're on the same page, your radius here is 6, not 12. So go ahead and see if you can calculate the surface area of the sphere and choose all that apply. Now, this is kind of tricky, so go ahead and take your time. There will be 2 answers. Just be careful. There'll probably be 2 answers. So once you go ahead and take a second and see if you can figure out the answers to part A. So hopefully you've figured out that A is the correct answer for surface area, and that you've also figured out that E is the correct answer. Now, if you use the pi button on the calculator, you'll get 452.39. But the person that made this slide used 3.14. So just so we're on the same page, E is also would be counted as a correct answer, but we use the pi button, so you should have gotten this. Now, it says calculate the volume of the sphere, run your answer to the nearest hundredth. So this time it wants you to go ahead and calculate using this formula here. Make sure that you go ahead and use pi and round to the nearest hundredth. Hopefully you come up with 904.79. Oh, I'm sorry. Actually, I made a mistake there. 0.78. Go ahead and take a brain break. Take a second to gather yourself. We're going to go over the second part of today's lesson, which is a review. Hopefully, if you're doing this on the computer and you're recording this, you can go ahead and pause this. When we come back, we'll get started again. So we're going to talk about real numbers, primarily rational and irrational numbers. So the easiest way that I like to put this is that rational numbers end or repeat. They end or repeat. And then also another way that you can do this, another way to think about this, is if you can write a fraction, if you can make the number into a fraction, then it is rational. All fractions are rational. So then irrational numbers never end We're not a very good writer with the mouse, but they never end and never repeat. Now, the word and is important there. It means both. The word or means that it only has to do one. So when I look at these, as soon as I see that it ends or repeats, I know it's a rational number. If I can't figure out that it never ends and never repeats, so the most famous is pi for irrational numbers. And then any square root that does not come out to be a perfect whole number. So like the square root of 2, I don't know what that is. But the square root of 49 is equal to 7. So one thing that we got to realize is if we see the square root, if it comes out to a perfect whole number, it's a rational number. If we see the square root and it does not come out to a perfect number, it's irrational, which can get confusing. But we're going to take a look at some examples here. And so it says, which of the following numbers are irrational? So first thing is, as soon as I see that I can write it as a fraction, I know that none of these will be the right answer because they're fractions, because these are rational numbers. So I can't have any of these as an answer because I can write them as fractions. I also know that this number here ends, which means it is rational. This ... means that it continues forever. I can't see a pattern, so this one is rational, or irrational, I mean. But this one, the 3 starts to repeat, so I cannot use that one. So A doesn't work because it ends. And C doesn't work because it repeats. And the others don't work because I can write them as fractions. Just something to consider. See how this one doesn't end and doesn't repeat? That means it's irrational. Now, given the number 0.82, we're going to do both part A and part B. Does the number terminate? Yeah, it definitely ends. So that means that this is a rational number. So we're going to put terminate. Terminate means end, where I'm just going to put the letter T for terminate, which means that this is going to be rational. Now, it says write it as a fraction. If you think about this, the number is 82 hundredths. So we could write it as a fraction by saying 82 over 100. That's one way to do it. If you have a calculator, on the other hand, and you use Desmo's scientific calculator, you could just type in 0.82 and see this little circle? It's going to tell you that it's 41 over 50. And we can reduce this to 41 over 50. Desmo's scientific calculator will help you with a lot of today's assignment. So this is 41 over 50. Now, this little line above here means that it repeats. And so I'm going to put the letter R for repeats. It also means that it's rational because it repeats. And then the same thing here is 81. The only difference is because it repeats, I'm going to write it over 99. And then I can just check to see if it reduces. 81 divided by 99. If I hit this fraction, 9/11ths. 9/11ths. Anything that repeats, you take the repeating part and put it over that many nines. So there's two digits that repeat, 8 and 1. It goes over 9, 9. And then you can reduce from there. So it says, what is the decimal equivalent of 4/9 and 2/5? State whether they are terminating or not. Remember, fractions just mean division. So this literally means 4 divided by 9. If you have a calculator at your disposal, you can do 4 divided by 9. And you can see that it is 0.4 repeating. So 4 divided by 9 equals 0.4. And then you can draw a little line above. And then we know that that means repeating. Now 2/5 is the same thing. 2 divided by 5. You can use the calculator, or you can just do old-fashioned hand division. Either one is fine. 2 divided by 5 equals 0.4, and it stops, so it's just 0.4. And then this one, we would just put it ends. Which of the following numbers is not irrational? So is not. We're looking for rational. So be careful. Sometimes they like to trick you with questions like that. So I know that this is irrational. So this one cannot be rational. I know that pi is irrational. It cannot. All fractions are rational. And then this one, it doesn't have a pattern and it continues forever, so it cannot be this one. So it says write the following equivalents of 2/3, 1 3/4, and 7/8. State whether each is terminating or repeating. So 2/3, again, you're going to use the calculator. You're going to find that that is 0.6 repeating. 0.6 repeating forever. Obviously repeats. 1 3/4. You're just going to type that into the calculator just like you normally would. 1. And then you're going to put the plus sign. This is going to be weird. 3 divided by 4, because this is really 1 plus 3/4. So see how it says 1.75? So this is equal to 1.75. And you can see it doesn't go on any further, so this ends. And then 7/8, do the same thing, enter it into the calculator. 7 divided by 8 is 8.7 or 0.875. 0.875. And again, it just ends. It doesn't repeat or anything like that. So we can put that this ends. So now this is separate from the number. I'm just letting you know. Ends. If it specifically says terminating, you might consider putting terminating if that's what it's asking you to put. But ends and terminates mean the same thing. How can the word irrational be used to describe both of these pictures? Now, here's what I would say is when this is a number that goes on forever, never ends, never repeats. I don't really like this image. I'm not the person that created this, but when people get angry, a lot of times they will go off on a tangent and they will just go on and on and on forever just because they're mad. But irrational numbers, irrational people is something to think about. Our lesson for today, if you go back to Canvas, is going to be Edulastic assignment. You're going to click here. Click in sign in with Google, and then you'll select your screen name for your Gmail account at school, and it'll automatically log you in. And so one of the things is we did lesson 1, today's lesson 2. So we're going to start this assignment, and then you're just going to go through and you're going to do these problems. Notice that they've given you the formulas right here. One of the things that I want you to consider doing is writing these down, because when you go to the next question, you're going to have similar type of questions and stuff. Remember that diameter is all the way across the circle. The radius is halfway across. So if the diameter is 9, this is 4.5. And you would simply just take a calculator and say, oh, well, if all the way is 9, then half of that I would divide by 2, and it'd give you 4.5. Something to consider. If you have questions or you need any additional assistance, please feel free to email me or reach out to me in some way. Have a good day.